audible?
Yes, ma'am, you're audible.
Yeah, okay. So we were going through some of the chemical properties in the last class. We did addition reaction, and as the name suggests, we are adding something. So in this case, we added hydrogen. Um, and can you tell me what was the final result? Why were we doing it?
Ma'am, so if there is like triple bond, we are breaking one bond and it becomes double bond, and like the hydrogen is replaced.
Yeah, yeah. So basically, we have to like in order to get a different hydrocarbon, a differently bonded hydrocarbon, basically, that's why we were doing it. So that got something different, right? Like in case of alkenes, when the bond was double bond broke and gave us single bond.
Yes.
We did the same for we did a substitution reaction also, but in this case we were adding something, but that is other than hydrogen, like chlorine, any other it can be any other functional group. So we took the example of chlorine, and we pass it on like in the presence of UV rays, we react hydrocarbon and chlorine to give us the product, and we can react it with more than one chlorines, and we will get our product accordingly. And this after that, the last thing we did was combustion, which is burning of carbon in the presence of burning of carbon chain, the whole carbon chain in the presence of oxygen, and as a result, we'll get carbon dioxide. Now, if how will you identify? Let's say this is my um let yeah, this is my stove, okay, and I have kept a utensil here, and you can see that the flame is blue in color. The flame, this is blue in color. So will it be a saturated hydrocarbon or unsaturated?
Saturated.
Is my question clear?
Yes, ma'am, it is saturated.
Yeah. So if you see blue flames, then it is saturated. And what colored flames will you see if it's unsaturated?
Yellow or red.
Very good. So if it's unsaturated, then you'll see some yellow or red flames. Now the LPG we use at our in our homes. So is that saturated or unsaturated?
That is unsaturated.
No, that is saturated. And we did one example of LPG. One question, remember where the question was that when we burn LPG, and that is a saturated hydrocarbon, but it still forms it still gives out some soot and forms a black layer on the utensil, right? So we studied there that the LPG is saturated. Okay, because it's natural gas, so remember it's LPG is saturated. Okay, but why are
Oh,
we getting the blue colored flames? Sorry, not the blue colored flames. Why are we getting the smoke, the black layer, soot around the utensil?
um, yes, because like there is less carbon dioxide.
Yeah, not the carbon dioxide. Our product is carbon dioxide, but there is less carbon. Okay,
Yes.
so because of that, not less carbon, less oxygen, and the carbon is unburned. There is less oxygen, due to which the carbon does not burn completely. Okay, so due to the less oxygen, the carbon is not burning completely, and as a result, that black soot is there on the utensil. That's all. That's all the chemical reactions we did, chemical properties. Now let's move on to let me let me share the screen. Just give me 1 second.
Ma'am, your voice is not audible.
Okay. Am I audible now?
Yes, ma'am.
Okay. So I was saying, the question says that when we convert ethanol to ethanoic acid, is considered as an oxidation reaction. Now,
Yes.
what is an oxidation reaction?
Adding of an element, oxygen, or removal of carbon dioxide.
No, 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 no. Oxidation, in the first chapter, we did oxidation reaction, right? Oxidation, two things happens in oxidation. First is addition of oxygen. Only
Remove.
oxygen will be added. Oxygen, removal of hydrogen, right?
Yes.
Removal of hydrogen. Now let's take, so ethanol, two carbons and OH, so it is an ethanol, and we are adding oxygen, 2O, like, or O2 you can say. And as a result, we are getting ethanoic acid, right? Two carbons are there, and double OH is also there. So this is the whole reaction, and this
Yes.
is called addition reaction. Why? Because oxygen, addition of oxygen is happening. Okay, clear? And hydrogen is also removed, but mainly because oxygen is adding. Why oxidation reaction? Or simple, because we are adding oxygen. Okay,
Yes, sir.
all right. Okay, and also C2H5 is C2H5OH is ethanol, which is an alcohol, right? OH is the functional group for alcohol. So
Yes.
ethanol is so this is alcohol, and when I'm adding oxygen, I'm getting ethanoic acid. Okay, so that's all for this question.
Ma'am, C2H5 is alcohol.
No, no, C2H5 OH is alcohol. See, OH is the functional group, and we call it alcohol. And with this alcohol, ethyl group is added, right? So we will call this as ethanol. Okay.
Okay.
Alright. Just give me 1 second. Okay, so the next thing is rectified spirit. Okay, this might come like in an MCQ or like one marker, that what is rectified spirit. So if I take 95% ethanol and just 5% of water, like there is a water solution, right? It's a ethanol solution, but in that, whatever I'm taking, so majority, that is 95% of that quantity is ethanol, and the lesser quantity, that is 5%, is water. So if someone asks, if there's a question, what is rectified spirit? So you can say when 95% of ethanol is dissolved in 5% water, that's all. A water solution, that is called a rectified spirit. Okay,
Okay.
not spirit but spirit. Don't use the I before I.
Okay.
Okay. Now, the next thing is denatured alcohol. It's pretty easy. Now let me explain it. What happens is, the alcohol consumption, in like the alcohol consumption is very high, right? In terms of beverages. So what happens is ethanol is used for like drinking purposes, for the beverage purposes, ethanol is used. Now this ethanol is also produced in laboratories, right, for the lab work. So what people do is, because of the high taxes on the actual beverages that are sold, that are sold on the shops, what people do is, to avoid those taxes, they try and consume the ethanol from the labs, like they start stealing it So because of that, what actions government or agencies have taken is they add something poisonous to this ethanol. In the labs, they add something poisonous so that poisonous, like they add a little amount of methanol or copper sulfide. So this won't affect the use of ethanol, but like this is not fit for human consumption, right? The methanol, copper
Oh,
sulfide, so these will harm, like these are poisonous to human beings. So what they do is they add this in the little amounts, in a way that they do not affect the property of ethanol, but they also, like, if someone consumes it, it will harm them. So that is what the government has done to prevent this stealing of ethanol, uh, or misuse of ethanol. So like if you want to give it a read, you can give it this a read.
ma'am, what is burage?
Where is it written?
Uh, Alcoholic burage.
Al- beverage, basically
Oh,
alcoholic drink.
oh, okay.
That is a V.
So, ma'am, like what they get in shops, like alcohol, for not
Mm-hmm.
consumption by in laboratory. That's why they mix some chemicals.
Yeah, because see, both the ethanols are same. The one they were selling in the shops and the one that was used for the laboratory purpose. Now, and that's why people used to like steal them or like consume them without, like, to avoid paying the taxes. So that's why they start adding something poisonous in a little amount so that it does not affect the properties of ethanol, but like at the same time is harmful for like human consumption. That's what they did.
Okay. Ma'am, you're stuck, I guess.
I was waiting for you to read, like, because you were reading. I
No,
was
I
waiting
was
for
stuck.
you to. Okay, then. Okay, so I'm
Yes.
gonna continue. So now, we will start with. Wait. Okay, so let. Now let's. So we'll do a few important. We'll study about the uses of ethanol, where all we can use it in real life. So
Okay.
first of all, the one we just did, denatured alcohol. So that is where ethanol is used. It is a constituent of alcoholic beverage, such as beer, wine, or whiskey. So it's used there also. Uh, One more thing, it's commonly used as a solvent for perfumes, fats, etc.
Oh,
And it is also used as an antifreeze. So this is an important property. It is used as an antifreeze, and it is also added in the petrol, and this petrol consists 25% of ethanol. Along, apart from like other constituents in petrol, 25% is ethanol. So you can learn these 3 to 4 because they might come like in a 2 marker or 1 marker. So these are the properties of ethanol. Now we'll start. So this is clear. They are pretty easy. Just one, they are used for drinking purpose, the beverage part. Then they are used as an antifreeze, and 25% of 25 in like the petrol, 25% is ethanol only. Okay. So now let's
yes.
start with soap and detergents. Now, till now we have been studying about carbon and how carbon for like has a property called catenation. Can you do you like can you tell me what catenation is?
Like carbon has a tetravalent property in which it can bond with four sides, and carbon can bond with itself, or it can even bond with some other elements. That's the catenation
Hmm.
property.
Yeah. Yeah, that's catenation. Now, so carbon is not the only element that follows or that goes through catenation. Elements like sodium or potassium, they also can go through catenation, which means they can also bond and form long chains of their own or with some other elements. Now we are talking about soap, right? Soaps and detergents. So what is the use of like sodium and potassium here? So how soaps are formed, basically, if you want to see a soap molecule, like the structure, so it will be a really long chain of either, this is the long chain of either potassium or sodium. Okay, potassium is K and sodium is Na. So either potassium or sodium will form a long chain, and at the end, this is carboxylic acid, and at the end will be a carboxylic acid along with carboxylic acid. Okay, so a long chain. This is the long chain of carboxylic acid till here, and you will see that sodium is attached, or even potassium, sodium slash potassium. Okay, so this is a soap molecule. You can read this also, that it is a soap is a sodium or potassium salt. This is what they're talking about, of some long chain of carboxylic acid. Okay, so this long chain can be like, this is the n number of carbons. N means you can attach as many carbons you want. Okay,
So
here
is it soap
this
we
part
use?
is clear. Sorry,
Is it like the soap
can
that
you
we use?
repeat?
Is it like the soap
Yeah,
that we
the
use for
normal,
bath?
like the soap and detergents we are using. Yeah, the soaps and detergents that we use in our life, this is what they're talking about. Okay,
Oh, okay.
so basically a long carbon chain, and at the end of the chain we have the carboxylic acid and sodium or potassium, any one of the element can be there. Now, why only sodium and potassium? Because they have the property, like they are easily they are sorry, just give me one second.
Oh,
All right, sorry about that. So what I was saying was like, why potassium and sodium only? Because they are water. Like if we want to use a soap or detergent, we need it for it to be soluble in water, right? Otherwise it won't be able to clean. So other metals are usually insoluble in water, whereas sodium and potassium can be easily dissolved. So that's why we use them for making soaps and detergents. Okay, so this was
okay.
like a little intro about soap, like what all metals are we using and why are we using. Now, hard water. Do you know what hard water is?
No.
What hard? Okay, so basically, hard water is something that comes from our tap, like the tap water. That is hard. Now, what happens in hard water is there will be like metals, not as in something solid, but there are metals mixed in that. We also have like we have ROs installed in our home. So what they do is they remove those hard metals, right? It is not like it's okay to consume them, but not all of us are able to digest them because they are strong metals. So hard water is basically water that contains strong metals. Okay, now the question is that why does soap work in hard metal, right? So that we already have. Sorry, were you saying something?
No, we're audible.
Okay, I thought you were saying something.
No,
All right.
no.
So Now, the first line they have said the same thing only, because hard water contains impurities of calcium and magnesium salt. Like I said, that hard water contains some metals. So, and the soap does not work in hard water because they already contain some metals, right? Like calcium and magnesium, and because the soap also has some metals in it. So what happens is they react, this salt and the metal, they react to form and magnesium salts of carboxylic acid. Okay, so this is the carboxylic acid at the end. If we use it in hard water we know has has some calcium or magnesium. So this basically at the end this replaces sodium and puts calcium or magnesium. So it forms entirely like a new compound. So that's not what we want, right? And if it's forming a new compound, that means it is not dissolving, the soap or detergent is not dissolving in the water. And that's why they are unfit for, that's why hard water is not used with soap or detergent. Getting a little confused. Okay, I'll explain again here.
Okay.
Okay, so let's say this is, so let's say this is the salt, right? Not the salt, sorry, soap. This is the soap. Now the why am I not using this detergent or soap with hard water? There are two types of water, hard water and soft water. And hard water contains impurities
Sodium.
of other metals like calcium. Sorry, what were you saying?
No,
Were
like
you
the
saying
hard
something?
water is sodium, right? And soft water is potassium.
No, 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 no. Sodium and potassium is in the soap. What
Oh,
molecule? Soap molecule has two things. One, a long carbon chain containing carboxylic acid, C double O, right? Carboxylic acid. Contain a
yes.
soap molecule will have a carboxylic acid chain, and the other thing it will have is either sodium or potassium. Okay,
Oh, okay, ma'am.
then
Ma'am, your voice is breaking a lot.
yeah, so this is one thing, that this is the, or is it breaking? Am I audible?
Yes, ma'am. Now you're audible.
Okay. So what I was saying is that this is a different concept. This we were talking about soap molecules. Okay. Soap molecule will have a carboxylic acid chain. This a long chain of carbon containing carboxylic acid, and it will also have a metal, sodium or potassium, any one of these metals. Now I also mentioned why only these metals, because they are easily soluble in water. Okay, so they can easily dissolve in water, easily soluble in water. Now, let us say that you've got your hands are dirty and you want to wash them. So you will use a soap, right? So that soap, if you let's say now you'll rub like the soap, if you're using that soap bar, then you'll rub it around your hand, and then like you'll see some bubbles, some bubbles forming, and you'll be easily able to like remove it. So the whole process shows that it is easily like soluble in water. Why? Because you put the soap bar under water and then you rub it around your hand, and that's why some bubbles are there. And you will like also the soap does not stays the same size, right? It keeps on decreasing, like with use it keeps on getting smaller. So that shows that it is dissolved, like it gets dissolved in water, right? It's getting smaller because it's getting dissolved in water. So that's why, so that soap contains either potassium or calcium. These metals are easily soluble in water. What we mean when we say that are they are easily soluble in.
Oh, okay, ma'am.
Okay, now do we avoid using hard water? with soaps and detergents. This is because the hard water already contain calcium and magnesium. Those are some other metals, or they already contain some metals. Now what they do is, when these two are reacting, right? So what happens is, this is sodium and calcium, they get replaced. So a new salt is formed, either of magnesium with, so a new salt will be formed of C double O Mg, the magnesium, or C double O Ca. So new salts of magnesium and calcium with carboxylic acids are formed, and we do not need that. Right? We need this detergent to dissolve away. We need this detergent or soap to like dissolve and wash our hands or our clothes. So, and if we are using it with hard water, it is very difficult for them to like soluble. So they are insoluble, and that's why we avoid water. Is it clear, or is it still confusing?
Ma'am, like we usually use hard water in our daily life, right?
Yeah, but it's not that, like it still contains less amount of these impurities. But yeah, for like washing our hands and like even clothes, we use hard water, but it's not that hard. It's mostly like towards the soft water side.
Oh,
Do you have any more questions?
no, ma'am. Ma'am, so the magnesium and calcium they replace sodium and potassium.
We can see that in this reaction. So they took a chain of 17 carbons, right? I don't know the name for that, but they took the chain of 17 carbon, because remember, we have got a long chain, right? And they have added carboxylic acid and sodium. So this is a soap which is containing sodium. Now this is the hard water, MgCl2. This is the hard water, and as a result, as you can see, the sodium is removed and is reacting with the chlorine, and the magnesium gets attached to this chain, to this detergent chain. So it's replacing. Okay.
Yes, ma'am.
Hmm. All right. And wait. And the same for potassium, a long carbon chain of carboxylic acid along with potassium, and when it's reacting with calcium chloride, the hard water, then it will like the calcium will replace the potassium, and see KCl is forming, and here instead of potassium we can see that calcium is here. So this is the reaction. This is what I told you, that they will replace. And due to this insolubility, this water is not soluble in, for hard water is not like hard water is not perfect or preferred for use like cleaning purposes. Okay.
Yes, ma'am. It's clear.
Will not like not dissolve, but it will take a lot of time. Okay. So that's why like it is avoided to use hard water.
Ma'am,
Clear? Do you
where
want? Mhm.
where can we find like a proper hard water?
Yeah, sorry. So what were you saying?
Ma'am, where can we find hard water?
Hard water easily in the sea, ocean, like sea, from the sea, rivers, all those water, those are hard water only. Like they contain salts of different metals, right?
Oh, yes, ma'am.
5866. And basically the metal impurities, those are the water that contains the metal has their impurities, they are hard water only. Now
Okay.
let's see, Now let's see the preparation. Like how can it be actually same thing? Hmm? Yeah, just I'm so sorry. Fatma, give me one more second. Wait. Okay. So hmm. Shall I continue or were you saying something?
No, ma'am, you can continue.
Okay. So let's not salts of soap formation.
Ma'am, your video is stuck and your voice is not audible.
Hi Fatima, can you see me?
Yes, ma'am.
Alright, I got disconnected. Let's continue from where we left. Let
Okay.
me share the screen. Okay, so we will first do like how the soap formation and then we'll continue.
Okay.
So soap formation is our next topic. Okay, so this majorly we will call it saponification. Saponification, I'll get to that later, but basically what happens is to get there, it's basically it's carried out in two different steps. So the first step is for the formation of this long hydrocarbon carboxylic acid chain, to which the sodium is attached, or even potassium. Sodium/potassium is attached. So that is why we are carrying out the first step. The main step would be this saponification, where the soap is actually formed, but we need this step. Yeah, sorry. But we need this step also, esterification, so that we can get our major product. So one of the product is formed here, then we'll react it with something else and we'll get our soap. So let's focus on esterification first. So esterification, the first thing is ester here. So basically the formation of ether or ester. Okay, so mainly ester, but ether also. So they are a type of ketones. Ketones we is a functional group we did, in which this is in which on both the sides, ketone is the functional group in which on both the sides we have the carbon, the different carbon chains on both the sides, and on the main functional group is carbon double bonded with oxygen. On both the sides we have the carbon chain, different carbon chains. So this is the basic, this is the most common. This is ester basically. So we'll have to form this ester first. So we'll take. Can you tell me what this is?
Ethyl.
So C2H5 is what?
Ethyl.
Ethyl. Ethyl. And we also have OH, right? This is a
Alcohol.
functional group. So what is this?
Ethanol.
Yeah, very good. So this is ethanol. And what is the second compound?
Um, Propanoic acid.
Hmm. Yes. Because we have two carbons and double OH, so ethanoic acid. So ethanol and ethanoic acid. So these two will combine to give us ester. To give us ester, not ester, ester, to form ester. Now, they will do this in the presence of concentrated H2SO4. Okay. And as a result, we will get ethyl ethanoate. That is the long carbon chain. No, that is basically our ester. So we have this C double bond O, basically like CH3, C double bond O, C2H5. So this is what, uh, if we look at this formula, we have C double bond O, R and R dash. So two different. Here we have methyl, here we have ethyl group, and here we have methyl group. So we have ethyl ethanoate and along with some water. Now we have one more step. Now we will react it with sodium hydroxide, because what we need this we need Na at the end also, right? To a carboxylic acid we need Na. So what will happen is the NaOH will attack here, remove this molecule and place Na here, and this will separate out, okay, with OH. So this will become again, let's look at let's take a look here. So this is the same product, we have kept it here, C12H H35 and C00C2H5. So the similar method. Now we'll add sodium hydroxide, NaOH, and as a result, this Na will attack here and attach, and it will get attached here. This is what we're talking, and this is what we need. And this C2H5 will get separated, and we have OH left. So C2H5 OH will get separated as a different product. So we have ethanol here. Okay. Clear? This is clear what is happening here.
Yes.
Basically reacting ethanol and ethanoic acid to form an ester, and water gets released. Now here it's CH3, but here it's C12H35, right? So don't get confused in that. It's just the quantity is different, right? Both the bases will be same. We'll take an alcohol and an carboxylic acid, but depending on our need, right? We need 17 carbons, so we will react accordingly, okay? Because we can't just take two carbon chains, because that will be a really small chain, okay? Am I audible? Did I get stuck?
Ma'am, you got stuck in middle.
Yeah, okay, so I'll repeat. So what I was saying is, here we have CH3. Let me erase this because it's looking really messy. So what I was saying is CH3. Here we have CH3, and here we have one carbon, and here we have 12 carbons, right? So I was saying, don't get confused in that. We will take the carbons according to our need. Okay, so this was kind of a general reaction they gave you to, so that you can understand how ester is formed. Now in the second reaction is what you will write or you will learn, so that when there's a question that how do you prepare soap. So in those reaction, write this where you have 12 carbons. Okay,
Ma'am, not the
that's
first one.
this is for explanation terms, kind of learn this, so that like if you're unable to remember, so this is kind of more for the understanding purpose. Okay.
Oh, okay.
Basically they are trying to tell you how ester is formed. We take alcohol and carboxylic acid, we react, and an ether is formed. Okay. And so this is what is happening. We have an ether here, and now we are reacting with sodium hydroxide. As a result, this gets OH and C2H5 reacts, and the remaining chain is binded with Na. That is what we need, right? This
Yes,
is
ma'am.
what we need. Now now similarly what happens here is, now this is our product. Now we don't need anything else. We'll take this and start reacting it. Now saponification is basically we're breaking down this molecule in the presence of a base of an alkali here is NaOH. That's all for saponification, breaking down a molecule in the presence of an alkali. And so this molecule will break down into two parts. This C4H8 will get separated and form OH right here. So C4, so butanol, and the remaining will get attached Na here. So we have, this is our soap molecule C17H35, COONA. So this is the soap molecule that we needed. Okay.
Yes, ma'am.
All right. So now let's move on to detergents, or let's first look at this. Detergents are also, we don't have a lot on detergents, just the same thing. We in this the difference is that the sodium salt is there, like in soaps we still have sodium salt, but the sodium salt is attached to a long chain of benzene sulfonic acid. This is the benzene and sulfonic acid. So here there's a long chain of carbon, and on this carbon the benzene is attached, and on this benzene we have sulfonic acid. Okay, sulfur and sodium. So this is the sulfonic acid. Okay, benzene is also a carbon chain, carbon in the form of chain. Do you know about benzene?
No, ma'am.
Okay, so it is carbon only, six carbons in the form of chain, but the difference is, like alternate carbons are doubly bonded. So if this is double bond, this will be single bond. then there is a double bond here, then a single bond, then a double bond, single bond. So alternate double bonds on a carbon chain. Six carbon chains, that is benzene. Okay, exactly six carbons should be there and alternate double bonds. So that is benzene. Okay.
So
Now,
three double bond
now,
and three single
sorry,
bonds. So like
sorry.
benzene has three double bonds and three single bonds.
Yeah,
Okay.
three is double, three single. All right. Now, the next thing is, just give me 1 second because other students are joining. Let me see. I want to complete this chapter, so okay, let's continue. So this is the structure. Like, this was about detergents. We don't have like a lot of details for that, but let's get into the details of how actually like the cleaning works. Like, what is happening on the atomic level, so that the dirt is removed from our clothes, or even our hands, and like how the cloth is getting cleaned. Now I'll explain it by writing it down. Can you see the screen?
Yes, ma'am.
Okay. So before